So next we will discuss adiabatic process. Adiabatic process. Now adiabatic process is defined as the process in which heat energy is not allowed to enter or leave the system. So we can write down the definition of this process. Adiabatic process is a process in which heat is not allowed to enter or leave the system. Leave the system boundaries, you can write. System boundaries. Now to fulfill this condition, we must have that the system boundaries, they should be, you can say, the system boundaries must be perfectly insulated. Number 2, the process must undergo very fast. So these are the two main conditions to achieve the adiabatic process. Now why we put these conditions? Because in adiabatic process the heat energy is not allowed to enter or leave the system as per definition, so delta Q is equal to 0. Now whenever there is any process, if we compress the gas within a confined space, now during compression there must be a change in internal energy of the system, so heat energy will be evolved from the gas. Now if the system boundaries are not, you can say, they are not perfectly insulated, the heat evolved will conduct it out of the cylinders. It will conduct out of the system boundaries, and what will happen that the temperature will move this lowered in the system, so it will defy the conditions of adiabatic process. So to achieve this process, the system boundary should be very perfectly insulated. Now the very good example of this process is internal combustion engines. Combustion engine. Especially during its power stroke. Now what will happen during power stroke? We burn some fuel in within a, you can say, compressed. When the fuel air fuel mixture is compressed, there is a spark and the fuel is burnt. At that instant, lot of heat is produced inside the piston and cylinder arrangement. Now this heat we try to convert all of this heat into effective work. So to achieve this, we need to make this process very fast, and moreover we want ki no heat should be, you can say, wasted, or no heat should be leak out of the system. So for that we also need very insulated boundaries. But in case of IC engine this may not happen, but the process made is very fast, so that we can achieve the adiabatic process. Now let us do this calculations for its various equations. Now we can draw adiabatic process first of in piston and cylinder arrangement like this. Initially you can say piston is here, now there is a gas inside the piston cylinder arrangement, and let us say here the coordinates at 1, this is P1, V1 and T1. Now there may be some process occurring in the system, like let us say compression, this power stroke. So during power stroke the piston will move backwards, so it may move up to this point. So due to, you can say, expansion of gas, so coordinates becomes P2, V2 and T2. Volume, pressure, temperature, everything changed. So during this process no heat energy is allowed to leave the system. So delta Q is equal to 0. Q cannot leave the system. Here also Q cannot leave the system. So the system boundaries are insulated, perfectly insulated boundaries. So you must draw system boundaries. Here again we can draw similarly perfectly insulated system boundaries. So this is your system. So now let us now in this case the gas equation used, the gas equation used is PV raised to power gamma is equal to constant. Now how this equation comes, you can see, refer any book. We will not go into that detail, but let us start from this equation. Now we also know that PV is equal to RT for unit mass, so we can convert this equation in terms of either pressure or volume. So let us start with first we put the value of pressure. So here we can get the value of pressure like P is equal to RT by V. Now this is equation A, this is equation 1. Now substituting the value of pressure P in equation 1. Now what we get? We get RT over V, this is P, multiplied by V gamma is equal to constant. Now here again R into T into V gamma minus 1, V gamma minus 1 from this V gamma minus 1 is equal to constant. Now here R is constant, here this is constant, so we can rewrite this equation like T times V gamma minus 1 is equal to constant. So this is another equation we will use while doing analysis for the work done. Similarly, in terms of temperature and volume, similarly we can also find the equation for in terms of from here, like volume is equal to RT by P. This we can get another equation in volume and temperature, in pressure and volume. So again PV gamma is equal to constant, substituting the value of V, value of V is equal to RT by P from equation B. ये वैल्यू पुट कर दी, so we get P into RT by P raised to power gamma is equal to constant. So again P into r raised to power gamma t raised to power gamma divided by p raised to power gamma is equal to k. I think I go very down. So move on to next page. No. P times r gamma t gamma over p raised to gamma is equal to constant. So from here we can rewrite this equation as p 1 minus gamma into r gamma t gamma is equal to constant. Now here r is constant, so we can rewrite this equation like p 1 minus gamma into t gamma is equal to constant. So this is another equation in terms of pressure and temperature, equation number 3. Yes. Now let us calculate the work done. Now work done in adiabatic process. Now we know that work done is equal to 1 to 2 p times v dv. Now we know that in this equation, adiabatic process, we have used this equation p v raised to power gamma is equal to constant. So we can substituting the value of pressure here, so we can write it as 1 to 2 here p is equal to constant by v raised to power gamma, so k by v raised to power gamma into dv. Now this is equal to k times 1 to 2 v raised to power minus gamma into dv. Now integral of this is k times v raised to power minus gamma plus 1 over minus gamma plus 1. Now this is equal to integral of x raised to power n into dx. This is equal to x raised to power n plus 1 over n plus 1. We use this relationship. So here we ultimately get work done is equal to k times 1 minus gamma and in the bracket sorry, here you forget to take this v1 to v2. So we get k times 1 minus gamma over in bracket we have v2 1 minus gamma. We can rewrite this like this, minus v1 1 minus gamma. Now again we can rewrite this as 1 by 1 minus gamma k times v2 1 minus gamma minus v1 1 minus gamma. Now we know that p1 v1 is equal to p2 v2 is equal to k. Now substituting the value of k here from here, now k is equal to p1 v1 and k is also equal to p2 v2. So rewrite this equation like this, 1 minus gamma into p2 v2 into v2 1 minus gamma minus p1 v1 into v1 1 minus gamma. Now this becomes 1 by 1 minus gamma. Now v2 into v2 1 minus gamma becomes 1 plus 1 minus gamma. p2 sorry, here is there is gamma, p1 v1 gamma is equal to p2 v2 gamma is equal to k. Just I taken the wrong values, so here gamma, so here gamma, so v2 gamma plus 1 minus gamma, this becomes p2 v2 minus p1 v1. Now this is the you can see equation for the work done for an adiabatic process, and we can also rewrite this equation. Also we can rewrite the above equation in terms of PV is equal to RT. So this equation can be written as W is equal to R times 1 minus gamma. You can do it by yourself, T2 minus T1. This is a very simple expression. Now in adiabatic process, delta Q change the energy is equal to 0. There is no heat energy, transfer of heat energy within the system or out of the system. So therefore, using first law, we know that delta U is equal to Q minus W. So here Q is 0, so delta U is equal to minus W. So again, you can also note this equation also, that the internal energy is inversely proportional to the work done. What does it mean? If work is done by the gas, then internal energy will be reduced. So this is the expression for the adiabatic process. Thank you.